In this video, we will try to figure out what do we exactly mean by natural logarithm. Now, natural logarithm is essentially the inverse of an exponential function. So, natural logarithm is an inverse of an exponential function, which means that essentially what we are doing is reversing things. So, what we are doing is reversing things. If y equals to e to the power x, then ln y, which is a notation for natural logarithm, equals to x. So, what is happening here? Here, your domain is now turning into codomain, and codomain is now turning into domain or range. Domain is turning into range, range is turning into domain. So, it's an inverse function. So, ln and ex are inverse functions. So, essentially, if we had x is here, y is here, now through the function we were relating e to the power x to y's, now we are relating y's to x by the function natural logarithm. So, if y is equal to e to the power x, then ln y equals to x and vice versa. Okay. Now, as we had certain important properties of ex, we will also have certain properties of logarithm coming in from there itself. So, we say that log of a product of two numbers is actually equal to the sum of the two logarithms, separate logarithms. So, ln y1 into y2 equals to ln y1 plus ln y2. Now, this is coming directly from here. This is coming directly from the property of exponential, which says that e to the power x1 plus x2 equals to e to the power x1 into x2. Now, how? I will just show you that. So, say that e to the power x1 is y1 and e to the power x2 is y2. Okay. So, we get e to the power x1 plus x2 equals to y1 into y2. Okay. Now, since e and ln are inverse functions, so I can also say that x1 plus x2 equals to log of y1 into y2. Now, what is x1? x1 equals to natural log of y1. Why? Because e to the power x1 equals to y1. So, I can also say that x1 equals to ln y1 and similarly x2. So, I get my property that log y1 into y2 is equal to log y1 plus log y2. Okay. Few more important things. Now, since e to the power 0 equals to 1, so what do you think will be log 1? So, when this turns into domain, okay, this turns into domain for logs. So, ln 1 will equal to y. ln 1 will equal to, 0. Okay. And similarly, ln of e will equal to 1. That's because e to the power 1 equals to e. So, ln e equals to 1. Okay. Now, graphically, when we are saying they are inverse of each other, graphically, what do we mean? Graphically, we mean that if my exponential function goes like this, the mirror image of it will be my ln x. The mirror image will be my ln x, and that's what it is out here. You can see it's an absolute mirror image of ln x. So, what is happening here? If this point is 1, 0, okay, if ex cuts y-axis at 1, that would mean that ln x is cutting x-axis at 1. Oh, sorry, so this will become, my mistake. I have written it opposite. I am saying opposite and writing opposite. So, this will become 1, 0. So, 1, 0 here and 0, 1 here. Okay. And this will be absolute mirror image. In exponential, what did I say? In exponential, I say that whatever number, or if we are talking about e to the power anything, minus x or plus x, anything, the y value will always be positive. Okay, the y value will always be positive. Now, since ln is an inverse function, y is the domain of ln. So, hence, the domain of ln, the natural logarithm, will always be positive. So, natural logarithm is only defined for positive x's. Okay, its y values can be negative, but it is only defined for positive x's. Whereas in ex, the y values can never be negative.